Hi students, welcome back to A Splinter of Winter Fraction Wonderland. Today we are going to be exploring lessons 7.2 and 7.3, multiplying fractions with and without models. Let's take a minute to review the lesson scale. By the end of this lesson, please remember that we want you to be at least at a level 3. Okay, this is our goal. We can use a model and standard algorithm to show the product of a fraction and a whole number. And we want to be able to do that with a model and by using standard algorithms. So we want you to be able to do it both ways. Let's review some of the mathematical practices you'll be using. Okay, so obviously for our mathematical practice, we're going to be making sense of a problem and persevering in our solving. We're going to reason abstractly and quantitatively. We are going to use a model to show our thinking. We're going to use appropriate tools. We'll be using fraction strips, fraction models. We need to attend to precision to make sure that we are checking our work. Okay, let's go ahead and get started. So for our I do, Miss Walker is setting up desks in her classroom. Each row has 8 desks. She wants students to occupy, that means sit, in 3/4 of the desks in each row. How many desks will be occupied in each of the rows? Okay, so let's see what the question is asking and which numbers we're going to work with. We know that we have 8 desks in each of these rows. We want the students to occupy 3/4 of these desks in each row. How many desks will be occupied in each of the rows? In total. In all. So now what we want to do is, we know that we have a fraction, 3/4. We want to multiply that by 8 desks in each of the rows. And we want to use a fraction strip model to see how many desks will be occupied in each of the rows in all. So we're going to pretend that this is our fraction strip. And this is going to be divided into 8 parts. Okay, we're going to pretend that those are equal. So we have 1, 2, 3, 4, 5, 6, 7, 8 parts. Now we want each one of those 8 to be broken up into fourths, okay, because we have a 4 on the bottom of our fraction. And we want each one to have 3/4. Okay, we're going to pretend that these are fourths. Okay, so as you can see, we have 1/4, 1/4, 1/4. In the next one, we have 1/4, 1/4, 1/4, and so on in each one of the rows. So now, if we were to take our 1/4 pieces and put them, fill up each one of these 8 rows of desks, okay, we would see that we have, let's count them up. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 fourths that we need to fill into our rows of the 8 desks each. Now we're going to fill up 1, 2, 3, 4, which is going to make the whole. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Remember that each one of these is 1/4. So if we have 1/4 or 1/4 and we have 4 of them in each of these rows, then this would be equal to 4/4, which is equal to 1. So we have 1, 2, 3, 4, 5, 6 that are completely full. So we can say that 3/4 of 8 desks in each row means that 6 desks will be occupied in each of the rows in total. Okay, 6 in each row. All right, now let's move on to multiplying with a fraction circle model. And we have Miss Addison's birthday is coming up in March. It really is. And she is planning to buy 3 pizzas to share with her team. If she ends up having 3/8 of each pizza left over after the party, how much pizza will be left in all? Okay, so this time we're actually going to start with our 3 wholes, and we're going to multiply by the 3/8 of each pizza that's going to be left over to see how much pizza we're going to have left in all. So this time we're going to use fraction circles because that obviously makes most sense when we're working with pizza. So we're going to divide, we're going to make 3 pizza pies. We're going to divide them into eighths. Okay, so each piece of each pie is 1/8. And you can see that we have 1, 2, 3 whole pizzas. And out of those 3 whole pizzas, we want 3/8 of each one. So we're going to want 1, 2, 3, 1, 2, 3, 1, 2, 3. So 9/8 in all. Okay, so this is going to be equal 9/8. And if we want to simplify it, we can say that that equals 1 1/8 pizzas that are left over. And I was able to get the mixed number, the 1 1/8, by asking myself how many times does 8 go into 9? We know it's 1 time with 1/8 left over. Okay, now let's multiply a fraction without a model. And this time we have Kendall, and she brought 24 cupcakes to school to celebrate her birthday. If 7/8 of the class ate a cupcake, how many cupcakes were eaten? Okay, so we know that we have 24 cupcakes in total, and we want 7/8 of these 24. So we want to know how many were eaten. What we're going to do is we're going to multiply the numerators, okay, the 7 and the 24, because this 24 is really the same thing as saying 24 over 1. So 7. Okay, so now we need to multiply the numerators. So 7 times 24, if you're not sure, you can do trial and error off to the side, but I know it's 168. And we are going to divide that by the denominator. And in the denominator, we have 8 times 1, or you can just simply say 8. So 168 over 8. So now, in order to simplify, we're going to ask ourselves, how many times can 8 go into 168? Well, if I were to set up my division like this, because this is really the same thing as this improper fraction, I would know that 8 goes into 16 2 times with nothing left over, and 8 goes into 8 once. So I know that 21 cupcakes were eaten. Okay, 21 cupcakes. So when we're doing multiplying fractions without a model, remember you multiply the numerators, you divide by the denominator in order to get your product. Now go ahead and take a look at your UDO problem. try it or pause the video and try to record it using both a model and standard algorithm in your notebook. We'll check it in a second. Okay, and we're back. Now let's go ahead and check our work. If we wanted to show 2/3 of these 4 boxes, we could have made, for the model, we would have had our 4 boxes, and we would have broken them into thirds, and we would have wanted to shade 2 parts, okay, 2 parts, shade it a little bit better, of each of the 4 boxes. And then we would have made our 4 boxes again and broken them into thirds. And remember, I'm doing this quickly, so that's super even. And we want to see how many full boxes we can fill up. So we have 1, 2, 3, 4, 5, 6, 7, 8 in total. So 1, 2, 3, 4, 5, 6, 7, 8. So we know that 2/3 of these 4 boxes would be 2, and 2/3 left over. So the amount of boxes of graham crackers that were used is 2 2/3 boxes. And if we wanted to solve this using the standard algorithm, we could have said 2/3 of 4. Remember, this 4 is really like saying 4 over 1. So if you want to rewrite it, you can. If you can just remember, we are only multiplying the numerators, that's fine too. So we could rewrite it like this. And we could say 2 times 4 is 8. 3 times 1 is 3. And then we need to simplify this improper fraction. And then in order to simplify, we're going to ask ourselves, how many times does 3 go into 8? 3 can go into 8 2 times, with 2/3 left over. So 2 2/3. Go ahead and reflect on where you are on your scale now that you have seen the lesson. Please record your understanding and your scale in your notebook, and we will see you in class tomorrow. Have a great night.